Hello and welcome to our channel again. Today we have Audi A1 2011 and this is TDI A1 2011. So the car has come to our garage with the symptom that when you start the engine, so when you start the engine management light is on and the coil sign on the dashboard is keeping flashing, or the coil sign on the dashboard keeps flashing. So let's investigate this together. So this is a 1.6 77 kilowatt TDI engine, or common rail TDI engine, and the engine code is CAYC, Charlie Alpha Yankee Charlie, Charlie Alpha Yankee Charlie. So CAYC. As you can see, the coil sign keeps flashing. So I'm going to scan the vehicle, and I'm going to see that what fault code the scanner can retrieve from the vehicle. Okay, these are the trouble code. As you can see, P069100 active, cooling fan 1 control circuit low, and the second one is P004700 active, and it says turbocharger or supercharger boost control solenoid A circuit low. So this are the two fault codes. Now we are going to physically test the turbocharger boost control solenoid, whether the vacuum can reach to the turbo vacuum actuator itself, or okay, this is the diagram of the vacuum connection, as you can see. So number 5 is vacuum unit. This is vacuum unit, and this is the, if you see here, it says blue color equals vacuum line for exhaust gas recirculation control function, and the gray color equals breather pipe to air cleaner housing, and green color equals vacuum line for turbocharger control function. So we are going to investigate the green line, and the red line is vacuum line from exhauster pump, or from the vacuum pump from here. So if you see that this is the vacuum output from the vacuum pump going here to the charge pressure control solenoid valve N75 here. It's connected to the bottom port of the solenoid, and then from the middle port it's output to the vacuum unit turbocharger, which is located on the turbocharger here. So we are going to check whether the vacuum is reaching from the vacuum pump here at this bottom port. Then back we are going to check that the vacuum is directing to the vacuum unit here, which is located on the turbo unit. So first we are going to check vacuum input to the solenoid, then we are going to check vacuum output from the solenoid to the turbo unit here. Okay, as you can see, this is the solenoid, or N75, and these are the vacuum connected to the solenoid. So I'm going to disconnect the bottom. Okay, this is the bottom vacuum line, which is coming from the vacuum pump, and I'm going to show you that as you can see, full vacuum is available. This is input to the solenoid. So coming from the vacuum pipe here, it means that out little there. So this is coming from the vacuum pump here, and as you can see, the vacuum connected again, that the vacuum is available. So the input is alright. I'm going to connect this back. Okay, I have connected this back. Now I'm going to check that. Where is it going to be here? Yeah. So this one is connected here. That's this one. So this is the output from here. So where is that? So this is the output from this solenoid to the turbo unit here. So if I connect this vacuum hose or vacuum point here and look, so I have connected but no vacuum is coming to the vacuum gauge here. As you can see, it stays on 0, so it means that the vacuum is not reaching the vacuum unit located on the turbo. So now you are going to check the electric side. Where is that? I cannot see yet. So now we are going to check here whether the power is reaching the solenoid or whether the ground side of the solenoid is alright. So we are going to check this. Okay, I'm going to connect the test light to the ground here. As you can see, and now I'm going to check pin number 1 at the connector. As you can see, nothing is happening. Pin number 2, nothing is happening. So this is going to be, because this one wire is thicker, it's 0.75 millimeter and the other is 0.35 millimeter. So the thicker wire is going to be the supply wire or the power supply wire. So now, see, we have no power reaching the solenoid here, as you can see. No. Now I'm going to check. So I have connected the test light to the positive side of the circuit. So this is connected to positive. As you can see, when I touch that somewhere here and there, now I'm going to see the ground side of the circuit. So if the ground path is provided by the ECU, this light should lead. But this light, using very, very small current, it's approximately 129 milliamps. So it's not going to damage the ECU. As you can see, the ground pattern is okay. The ground pattern is alright. Okay. Yeah. Okay, this is the wiring diagram. This is the charge pressure control solenoid valve N75, this one, or the turbo actuator control solenoid in another word. So if you see here, so this is the power wire or the power supply wire to the solenoid, and it's 0.75 thicker, and the other is which is 0.35 thicker. So this is the power supply, and as you can see, this is connected to J623. J623 here, it's the engine control unit. So if we go and trace this wire where the wire has come from, if you see here, it's C11. If you see here C11, it says connection in radiator fan wiring harness. See applicable current flow diagram for radiator fan. So if I click here, it's going to illuminate here. So now I'm going to go to the radiator fan to trace this wire where this way downward, where has it gone, or upward, where is it come from. So if I go here down, I'm going to page radiator fan control unit. As you can see, this is connected back to C11 where we have come from, and this wire has come from a fuse box. So now from C11, this power supply wire has gone to SC6. SC6 here, it says that fuse number 6 on fuse holder C, and this is located on ST3. ST3 is here. where is that? That's ST3, fuse carrier 3. So if I go to the fuse box, okay, fuse box, we are going to SC here. Here, I'm going to click on this, and this is going to be left hand drive. If I scroll that down, and this is going to be location fuse holder C or SC for model with right hand drive. So if I go down, so that was ST3, so fuse carrier number 3 fuses. If I click on this, and remember it was fuse number 6, so let me show you that this is ST3, so to the side where the front side is. So the fuse 6 is going to be 1 2 3 4 5 6, that's going to be this one. And what circuit the fuse is responsible for, so this is S2, so this is S3 line, ST3 line of the fuse, ST3 line. So this is fuse number 6. Fuse number 6 on fuse holder is going to be 10 amps, and this is going to be responsible for radiator fan control unit G293, charge pressure control solenoid valve N75. Remember we had 2 fault codes, and this fuse powers radiator fan control unit and charge pressure control solenoid valve N75 too. If remember, both had the low voltage DTC or diagnostic treble code, and also it activate, so solenoid valve N75 activated charcoal filter system solenoid valve, that's going to be on petrol engine valve N1N80, camshaft control valve 1N205. This may also be on petrol engine turbocharger air recirculation valve N249 intake manifold. So anyway, our focus is on this too. So now I'm going to check the fuse first. If we had the fuse serviceable or in a working condition or in a serviceable condition, then we are going to investigate that the wire is broken between the fuse or somewhere between the solenoid valve N75. So this is fuse number 6, and it's going to be this fuse. So it's going to be this fuse. So 1 2 3 4 5 6, it's going to be this one. Okay, I'm going to remove this cover. Okay, I have removed the cover. Now I'm going to connect my tester to a good ground. Okay, now ignition on. Okay, ignition is on. So I'm going to check fuse number 1. Fuse number 1 is okay. Now fuse number 2. Other side of the fuse number 2. So fuse number 2 is also okay. Fuse number 2. Fuse number. Okay, I'm going to straight check fuse number 6. So 1 2 3 4 5 6. So 6 here. Not. So other side of the fuse, as you can see, this is another side of the fuse. If I move to the other side of the fuse, it's so the fuse is blown. So I'm going to renew this fuse with the same current rate, and then see if the current is reaching there. Okay, this is the fuse rate, it's 10. And so if I remove this fuse, so I'm going to remove that from here, and as you can see, the fuse is blown. So but I'm not sure how it means. So this is 15 amps, so I'm going to replace that with the same current rate. Okay, this is the same current rate, fuse 15 amps, as you can see. So I'm going to put that in. Okay, now I'm going to check that if the fuse is still alive. This is going to be the problem because the fuse has blown again. Where is that? Let me take that out again. Yes, the fuse has blown. So give me one. Now I'm going to disconnect the solenoid. Then put another fuse and see if the fuse stays alive. So I have disconnected the solenoid here. So I'm going to put another same current fuse. Okay, as you can see, this is one side of the fuse, this one, and this is the other side. So the fuse has blown again, in spite of that I have disconnected the charge air pressure solenoid valve N75. So I think it's going to be the radiator control circuit, radiator fan control circuit. So I'm going to investigate that one. And I had to mention, but I forgot to mention, that the turbo unit is recently replaced. As you can see, it's marked, and you might be able to see that from here. That's recently replaced because of this problem. So as you can see, so I should have told you before that, but unfortunately I forgot at the beginning. So as you can see, it's marked and it's newly built. So now I'm going to find the radiator fan control module. So I'm going to find that, disconnect that, and then renew the fuse and see if the fuse still keeps blowing. Okay, if you can see, this is the radiator fan connector, this one. So I'm going to disconnect that. I think the radiator fan control module is integrated within here, and this is the connector. I'm going to disconnect this one. Okay, I have disconnected this connector here, as you can see. The connector is here. If you can see, I have disconnected the connector. Now I'm going to renew the fuse again and see if the fuse still blowing. And this is the fuse. I'm going to put that fuse again. Okay, now I'm going to turn the ignition on. So, oh, it has gone again. So it means that the circuit is shorted to ground somewhere. Let me check that again. Okay, ignition is on, and I'm going to check. As you can see, it has blown. So it means that the radiator fan control module is also okay, because I disconnected that one, and also the charged air pressure solenoid or turbo vacuum solenoid control valve. So but the fuse is still blowing. Okay, as you saw, with the radiator fan control module disconnected and the turbo vacuum solenoid control valve disconnected, the fuse is still keeping to blowing. So this time I'm going to trace the wire loom to trace the circuit of the turbo solenoid control valve and the radiator fan control module power supply wire. Okay, as you can see, fuse number 6 on SC6 supplies power to the radiator fan control unit. I disconnected that one. The fuse is still keep blowing. I disconnected charge pressure control solenoid valve N75, and the fuse is still keeping blowing. So this one, I'm not sure whether this vehicle is occupied with this device, activated charcoal filter system solenoid valve 1. I think this is going to be for petrol engine or not. So I'm going to find out this later and disconnect this one as well, and then check the fuse, renew the fuse, and see if the fuse keeps not blowing. So this is also responsible, this fuse, for camshaft control valve, but I'm not sure whether this vehicle is occupied with this control valve. Turbo charger air recirculation valve N249. I also don't know whether this vehicle is occupied with this N249. Intake manifold fluff valve. So I'm going to disconnect this from this one, see So this one, and also exhaust gas recirculation cooler changeover valve. So I'm going to disconnect this one, this N345, N316, and see if the fuse keeps. Okay, I was able to prevent this disaster happening. As you can see here, this was short and the vehicle caught fire. So thanks to this one, that this one survived the vehicle, as you can see here. So I'm going to show you, this is the wiring of the auxiliary pump. I'm not sure if you can see, this is the connector and the wiring harness of the auxiliary pump, this one. So I'm going to share this experience with you because I was keeping disconnecting related components to this fuse. So every time I disconnected a component and then I renewed the fuse, but on the third time, so on fourth time when I replaced the fuse, so this caught fire, and as you can see the connector is completely melted. So the best way is to complete the short circuit is by this tester light. So if you connect this side to the battery positive or to the power side of the circuit, so which is alive, and then connect this tip of the tester light to a load side of the circuit where it's shorted, so that will keep lighting or illuminating until the short circuit is cut off, until you keep disconnecting component until this light turned off. This is the best way because I think when I disconnected many relevant component, so the current was directed only to one direction. So because this was straight away short to ground and there was no resistance, so when I cut another path of the current which was fed by the circuit, and so unfortunately this melted the wire and the vehicle caught fire. So I was able to do this. So I strongly suggest that whenever you work on the electric circuit, or if that's a short circuit, that every time keeps fuse blowing, so you have this in hand. So to bring a short circuit to alive, connect this to the battery positive or power side of the circuit where the circuit is alive, and then connect this to the load side of the circuit, and then we'll continue to illuminate until you disconnect it or you point the part where it is shorted to ground. So now I'm going to order a new auxiliary pump and repair the wiring harness, and then but I was lucky that as soon as the fire started, this was very close to me, so I put the fire under control. So I turned the fire off, and hopefully that just a short part of this wiring harness is needed to be renewed, as you can see. Oh my God, look. Okay, this is the relay. It's J925. Both circuit of the relay, load circuit and also control circuit of the relay, are fed by the fuse number 6, which was keeping blowing. So this is the relay. If I bring you to the detail here, it's J925. It says heater element relay, and this is for the N79, which is heater element for crankcase breather. And also, if I take you back here, 5, and as you can see, so this is the relay pen 87, or the relay contact output, or so I have to say it's a load output to the load. So as you can see, this is also feeds by the fuse number 6. So the contact side, I think it's going to be pen 86 is connected to the fuse when the relay is energized, so contacts are closed, and so the pen 86 at the relay, pen 30. So the fuse number 6 supplies power to pen number 30 at the relay, and also to pen number 86, which is the control side of the relay. So when the contacts are closed, so pen 30 at the relay and pen 87 are closed, so power reaches here, down here, and so power is supplied to V400 or it's called pump for exhaust gas recirculation cooler. So if I bring you here, that's here, as you can see, and it is pump for exhaust gas recirculation cooler. So when the relay is energized, contact at pin number 30 and 87 are closed, and then the power comes straight to the EGR, pump for exhaust gas recirculation cooler. So for the EGR pump cooler pump here. So I'm going to follow this side. If I click here, so let me, where that can take us, that's here, as you can see. So this is connected to the exhaust gas recirculation cooler pump here, and I'm going to show you in O2 data too, because this circuit is showing just for this one, but it also supplies power to the, so when the relay is activated, it's actually send power to this, to N79, which is the heater element for crankcase breather, and also it sends power to the EGR cooler pump. So if I take you to the cooler pump here, it's going to be this one, yeah. So what has happened, because this two wire shorted together, this is pin number 1 is connected directly to the earth or to the ground, so this two wire are stuck together. I'm going to trace that. I'm going to expose the peel the wiring harness skin or cover. So, or I'm going to expose the wiring harness from its cover, and then see up to where these two are stuck. This is the supply wire, power supply to the V400 or EGR cooler pump, and this is the earth. So now I'm going to show you at the vehicle. Okay, as you can see, the ground wire, which is brown color, and the power, which is white and red, they are both stuck together, melted to each other. So I'm going to split this. This is going to be a headache for me, as you can see, both stuck together. Now I'm going to show you the relay location, this relay location. This relay, yes, I think it's this one. I'm going to show you the relay location. So J925, J925. So location, that's going to be here. Okay, the J925 is going to be this one. So location for model with left hand drive, and this says our A is right hand drive. So if I click on this one, so this is going to be relay number 4, this one, and here it says heater element relay J925. Oh my god, that's okay. So I'm going to do that off camera, everything. I'm going to take new wire, new power supply wire, and then separate earth wire to the earth point, and this is going to be the earth point somewhere. If I so I'm going to find the earth point where is where it is earthed, or where is it earthed? I'm not sure, English is no good. So then take new ground wire from V400 or EGR cooler pump to the earth point, because now the power wire and the earth wire, power to the pump and earth from the pump to the earth point, is stuck together. They are melted to each other and shorted to each other. Okay, as you can see, these two wires melted to each other up to here. So after that, they are splitted, they are okay, they are all right. So up to here, I'm going to put new wires, or I'm going to, as you can see, so now inside the wiring room, both are splitted, both are not touching each other or not melted to each other. So this is good news, if you can see here. So both are. So anyway, I'm going to check continuity test as well. So let me check continuity of the two wire. this is this one. So as you can see, one read of the voltmeter on this one on the white and red, and the other is on the brown one. So when I check here, it says 47 kilo ohm. So if I directly short these two together, so if I short this together, and as you can see, it comes to 1.1. So if I shorting this direct together, so now I'm going to repair the connector. So I've got connectors same heavy duty. These are with the 1mm thicker wire. So you need to get the same heavy duty, because when I went to the scrapyard and there was variety of them, so one I had very tiny wiring, so that's going to overheat again and cause the problem again. So I found same gauge. I have found connector with the same gauge wires connected to it, and so now I'm going to install that one, or to replace or to connect the connector to the wiring loom. You can see this is very I think it's tiny wire, and this is the heavy duty one, or this one compared to this one. Okay, if you happen to the same situation as me, because as you can see the wire color is different, so how would you know which one is the power supply, which one is the ground wire, and which one is the signal wire? If you put the pump like so, so this is going to be pin number 1, this one, left hand side. The middle one is going to be pin number 2, and this one is the right one. This one is going to be pin number 3. If I show you on the wiring diagram, so this is the pump. Number 1 is going to be the arc or ground wire here, and number 2 is going to be the power supply, and number 3 is going to be the signal wire to the computer. So if I show you here, if you can let me zoom that, and if you not sure, so once again, okay, this is the pump. As you can see, if I hold pump like so, so number 1 is going to be the ground wire, number 2, the middle one, is going to be the power supply, and number 3 is going to be the signal wire. Let me, if I, where is that? That might be. Now you will be able to see clearly. So the middle is pin 2, and this one is, oh my. So 1, 2, 3. 1, middle 2, this side is 3. Okay, I have done the repair. I have purchased new connector for the EGR cooler pump. So I used first the heat shrink with the soldering ring on it. I highly recommend that. This is very good. And then I used the normal heat shrink above the heat shrink with the soldering ring. So because sometimes when you heat up this makes a puncture somewhere, so I put the normal heat shrink on top of that to fully isolate the wire, as you can see. And this is the connector. So and this is the pump. This is genuine Volkswagen Audi part. And for this 1.6 engine, 1.6 TDI common rail CAYC engine, this is used for the EGR cooler function, so to pump coolant to the EGR cooler. So now I'm going to put insulation about this and put everything together back, then put the fuse back on and see if the power is supplied everywhere correctly. And I will also share the adaptation procedure with you as well if this pump needed adaptation to the vehicle. Okay,
I put everything back together. I have installed the AGR cooler pump, and I have reconnected the battery, and now I'm going to put the fuse again and see what is going to do the fuse. As you can see, as you can see, this is because there is a wall, I cannot open the door more than this. So if you see, yeah, so anyway, this is the fuse. It's in Volkswagen service manual, fuse number 6, and in UK O2 data it's fuse number 34. So if you can see here, that's just there. So actually, this is the fuse. It's number 6 in ST3 on Volkswagen service manual and number 34 on O2 data here in the United Kingdom. This is the fuse. So now I'm going to turn the ignition on. So ignition is on now, and now I'm going to check the fuse for use. As you can see, it's one side of the fuse, and this is another side of the fuse. So one side and another side. So now the ignition is on and the fuse stays alive. So now I'm going to check that. I cannot open door more than this. That's the reason. Anyway, I will show you later the fuse. Okay, this is the pin number 1 power supply. I'm going to check here. So the test lead is connected to earth here, and I'm going to check here. As you can see, power is reaching here. Now power is reaching here. Power is reaching here. Power is reaching to the EGR cooler pump too. And here, let me bring this little bit down. So this is very blurry. So if I you might be able to see the pulse width modulation. If I put that here, sure, because I'm sorry, this is too blurry. Oscilloscope. Okay, with another oscilloscope you might be able to see that's the pulse rate modulation. So as I told you previously, and because the power is not coming to the turbo actuator solenoid control valve here, so now if you see that's controlled by the ground side, so by the control wire, or the it's not controlled from the power side, it's controlled by the ground side. So constant power is coming here. As you can see, this is pin number 1 is the power supply to the solenoid control wire, and as you can see, so this is connected to ground here. So as you can see here, so constant power is coming to pin number 1 and going through the solenoid and coming back, and that's controlled by the ECU on the ground wire of the solenoid. So as you can see, the pulse width modulation now, the on time is approximately 95%. Let me show you how much is the on time. So if I go back 1 second, it's going to be duty cycle. So voltmeter DC, 1 second, it's voltmeter DC or setup. No. So anyway, back 4-channel scope. Okay, now the on time is approximately 95%. So now I'm going to start the vehicle, and then I'm going to show you when the engine is idling how much is the on time of the or how the pulse width modulation is changing, or even it will stay like so. I'm not sure if the mic can pick up because some ticking noise coming from this solenoid, and as you can see, this is the pulse width modulation. As you can see, they are slowly changing. Sorry for the blur screen. So I'm going to wait or actually I can hear some ticking noise, and now I'm going to show you that power is also coming here too. So give me 1 second to show you that too. As you can see, power is coming to the EGR cooler bypass control solenoid as well. Okay, this is the pump connector. It's cooled good. It's 21 degrees, so it means that it's not there is no any electrical circuit problem, so it's going to be hotter because it circulates the hot water. But anyway, right now it's fine. This connector here. How many garages this vehicle was in? Look, no one, just you. Okay, now I'm going to show you that the vacuum is reaching. Look, the vacuum is reaching to the turbo actuator, as you can see here. And this is the vacuum gauge. If I disconnect the vacuum gauge, okay, and that the vacuum gauge returns to 0. So if I connect back vacuum gauge to the vacuum line of the turbo actuator, see, very happy with this repair. So thanks for watching. If I'm going to this is right now disconnected. If I disconnect it, look at the bar of the actuator. It's going to move. Look. Connect. Bar move downward. Disconnect. Bar move upward. Connect. Bar move downward. Look at the red dot on the bar. Okay, as you can see, all 4 codes have returned to passive status or to history, as you can see here. And the engine management light is still on because when I was testing and also disconnecting some connector and then start the engine, and the engine has been running since then. So now I'm going to clear every fault code, and as you can see, previously it was current, now passive. So which one? This I created this one, the number 1. So the second is passive now, as you can see. The third is also passive, this one, and this one I created to the turbo boost control. solenoid. So this is passive too, as you can see. Now I'm going to clear the fault code. As you can see, the engine management light is still on, so I'm going to turn the engine off, on again, and clear fault code. Okay. Yes. Okay, as you can see, treble codes are not detected, so I'm going to go back and read treble code again. So very happy, no treble code. So I'm going to start the engine now. So engine management light off, ESP light off. So I'm going to move forward the vehicle and show you that which views was that. So bad English. Okay, it was this fuse, this fuse. So from the top 6, 1, 2, 3, 4, 5, 6, and in O2 data in United Kingdom number 34. And I'm going to check it because it was keeping melting. So and the temperature is 16, so which is very good. So that's that. So it was this one. Here's number 6 from the top and 34 in O2 data United Kingdom.